afternoon نبعت لكم عليها announcement على الايميل. Check النهارده for an announcement about an extra session tomorrow. There is another session on Monday. بكره محمد هيوريكم حل بعض مسائل من الامتحان. Monday دكتور حاتم هيعمل session for problem solving techniques على من مواضيع من chapter 2 and 3. Right now, check your email النهارده for the announcement. There's one more session that we just asked right now على maximum. هي سهله نعمل لكم ان شاء الله another session على maximum. ممكن برضه بكره دي ممكن يبقى في سيشن رانينج على الامتحان وسيشن رانينج على ماكسيمم بعدين. مثلا من الساعه 2 ولا حاجه كده.
عندنا حاجات.
احنا اتفقنا مع مستر محمد انور ان هو هيبدا يشرح لنا منهج الماث تايم الاول. هنبدا من النهارده من 1:30 ل 3:30 في قاعه 127. هنبدا الاول بالفانكشنز وبعدين هنمشي كل حد واربع وخميس بالطريقه دي والمواعيد هنزلها على الجروب النهارده.
في ناس عندهم توتوريال
طيب I have lots of extra sessions. وبوست اوسايد ماي اوفيس هتبقى برنتد بس للستودنت نيم والدرجه مش هيبقى
على درجه على
اوسايد ماي اوفيس. اول بكره مفيش اسماء يعني I'm not gonna print names.
اي يعني؟
I'm gonna print student number والدرجه. تمام؟ اللي عاوز يشوف ورقته بدايه من بكره هتبقى الورقه بتاعت حضرتك مع النهارده اخر يوم. اوكي؟ طيب we have some concepts that we would like to talk about today. The substitution method. And we stated last time that a few lectures ago, we talked about the chain rule. And somebody remind us what the chain rule was for? The chain rule for differentiation.
Implicit.
What was it for?
Implicit differentiation.
Okay. So how did I used to find d by dx? Cosine of x squared. Cosine of x squared times 2x. So what is the integration of 2x cosine of x squared dx? Okay? That integration becomes sine of x squared plus constant. Okay? So, what is the format of this function? 2x times cosine of x squared. Okay? What is this? And what is this? If I can find a function and its derivative multiplied together, that can give me a hint about a specific substitution that I get to help me get the integration. Okay? Let us see how this works. Okay? What is the integration of x squared plus 2 to the power 5? Let me suggest a variable u that's equal to x squared plus 2. Okay, x plus 2. Now du is equal to dx, right? So in this substitution that I just had, if 2x is equal to u, so dx is equal to du. Okay? Then dx is equal to du, and I am integrating actually u to the power 5 du. What is the integration of u to the power 5 du?
1/6 u power 5.
Some cooperate. Okay? There is just a type here, this is x plus 2, not x plus 6. So, the integration of u to the power 5 is equal to 1/6 u to the power 6 plus constant. And then, since the original equation does not have u, I need to bring back x. So I take u to the power 6, I put x to the plus 2 to the power 6 divided by 6 plus constant. This is actually plus 2. Okay? Let's take another example. What about the integration of 1 plus x squared times 2x dx? 1 plus x squared times 2x dx. What would I suggest for u this time? Okay, so this is the integration that I have. Integration of 1 plus x squared times 2x dx. U is equal to, what is your suggestion? 1 plus x squared. Any other suggestion for you? Anybody can suggest another u? What we're trying to find right now is again a function times its the derivative of what's inside this function. Okay? What about if 2 squared is equal to 1 plus x squared? Will this work?
Yes. Yes.
Yes? No? It will give me the same result?
Will give the same result.
Okay, let's see. Let's see. Let's take the first one. Okay? The integration of 1 plus x squared times 2x dx. And basically what I'm saying here is u is equal to 1 plus x squared. Then du is equal to 2x dx. Okay? Then that integration becomes the integration of square root of u times 2x dx is equal to du. Did I make a mistake in the substitution so far?
No. To explain.
I am differentiating this equation. equal to, this is constant, goes to 0. The differentiation of x squared is 2x dx. Okay? This is total differentiation for both sides. Now, what function if I differentiate it will give me the square root of u?
2 over 3.
2 over 3.
2 over 3.
This is equal to
2 over 3.
2 over 3.
U power 3 over 2.
U over 3 over 2
Plus
plus control.
Okay? That's the integration. Now let's take the other one. And now u squared is equal to 1 plus x squared. So 2u du is equal to 2x dx. Okay? Now substitute in the original to the integration of u, and then this 2x dx is equal to 2u du. Okay? This is the integration of 2u squared du. Integration of 2u squared du. This is equals to
2 over 3
2 over 3 u to the power 3
plus
d
control.
plus c. If I substitute back, this is equal to 2 over 3. What was this one? Okay, which is the same as the first one. So my selection of u could be different. You can select a specific u, I can select another u. Okay, selection of u need not be the same. Let's take another example.
دكتور
Yes.
حل المسألة دي ده لك كام سؤال؟
That's it. And then you simply substitute back. Okay? You substitute back what u was, which is 1 plus x squared to the power 3 over 2, 4 square root of 1 plus x squared to the power 3 plus constant. Okay, what about if I just have the integration of the square root of 1 plus x squared without dx?
مش عارف
Will not be
بالنسبة لإيه؟
able to
ما ينفع الانتجريشن بالنسبة لإيه؟
Can I find a substitution that works in that case?
we can
What function might help me do this?
higher bound.
Okay, I can find a substitution but not a polynomial. I can find a substitution that is trigonometric substitution. We're going to come back later in the course to find about trigonometric substitutions. And sometimes I cannot find any substitution, like the example that we took last time, like the square root of 1 plus x to the power 4. I cannot find any substitution in that case. Okay?
حضرتك بتقول لو مفيش 2 اكس صح؟ طب انا مش هينفع مثلا ان انا اخد لو مفيش 2 اكس يعني 1 بلس اكس سكوير 1 بلس اكس سكوير دي اقسمهم دي بلس
What you're talking about is that, what about if I have the quotient rule? Okay, this is the chain rule. The substitution is always with the chain rule. Okay? Yes.
حضرتك انا مثلا عملت 1 بلس اكس سكوير دي خليتها يو من نفس الايكويشن جبت الاكس بكام؟ in terms of u
Mhm.
معوض بيهم في الايكويشن دي وعملت انتجريشن وانا جبت الانتجريشن عوضت تاني بالاكسات ما تحطليش الرقم ده في الاخر. هل ده انا عارف ماشي غلط؟
اكيد في خط غلط.
Probably yes. Now let me give you, if I have integration from 0, if I want to integrate f of x dx, and I want to integrate this from 0 to x. If I integrate it from 0 to x, f of t dt, or if I integrate it from 0 to x, f of u du. Is there a difference between these forms?
لا انا فاكر عقد.
Is there a difference between these forms? What is the difference now?
Well, the first term, if we integrate f of x from 0 to x, we're using the same term. But in f, the function in terms of t, we're integrating, we're using a different term.
Okay. Let us make the substitution. T is equal to x. dt is equal to dx. Then I'm going to substitute everything in terms of x again. Or u is equal to x. du is equal to dx.
Then it's the same.
Okay? It's the same. So, the variable that I use inside the integration is called the what? The dummy variable. What do you mean dummy? The word dummy, what does it mean?
مش لازم اشتري.
شوفوا الارجوز بتاع زمان؟ ماشي الراجل كان بيلبس ساعة في ايده كده ويعمل حاجات كده. This is called a dummy. ماشي؟ dummy. Actually, the dummy is not doing anything. It's just the guy who's holding it. So the dummy variable for integration, I can use it inside the integration because I'm going to substitute it back. Okay? So this is the comment that you made last time. I wanted to mention it when we had a chance to look at substitution. Okay, what about this one? What about this one? What is u?
4x minus 1.
U squared is 4x minus 1.
4x minus 1 is equal to u.
U squared.
Okay, 4x minus 1 is equal to u. And what is du in this case? 4dx.
بس كده.
And then you put back, don't forget to put back x. Don't forget to put back x. Why did the substitution work? Why did the substitution work? What is the power of x under the square root? 1. The power of the square root, x under the square root is 1. This is why the substitution worked
إذا نفس القائمة.
this time. Okay? So, now, the way that we were going about finding the antiderivative, the integration of a specific function, is by comparing the table. Okay, we have a table of differentiation for functions, a differentiation for a polynomial, differentiation for a logarithmic function, differentiation for a trigonometric function, and we always wanted to find what function, if I differentiate it, will give me this. Now, the concept of the antiderivative led us to the concept of integration. Today, we learn another way that will help us find this antiderivative. We call that the substitution method. For the rest of this lecture and the next lecture, we're going to be talking about applications for integration. Applications for integration. When we started to talk about differentiation, we had several applications for differentiation. Can somebody remind me of some of these?
Maximum value. Extreme value.
Okay, changing rates. This is the first one, is that we use differentiation to estimate the rate of change. Okay, and hence we calculated, we had the function called displacement, and we said that the rate of change of displacement is the
Velocity.
velocity, and hence we calculated the velocity. And this was the first actually time we talked about the applications for differentiation. And then what else we talked about as an application for differentiation? Optimization. Okay? We want to maximize or minimize. This came later in chapter 4 when we learned about the local minimum and local maximum. Okay? We said that this is when we are talking about optimization subject to a constraint is actually equivalent to finding a local minimum or a local maximum for that function. So optimization. What else did we talk about in terms of applications?
Related rates.
Yeah, plotting a function, yes. Related rates.
Yes.
Related rates. Okay.
But related rates by using chain rule.
Yes, and related rate by using chain rules. These are all different applications for why this concept of differentiation was relevant to our lives. Let's talk about what.
دكتور الطريقة اللي فاتت ما تنفعش كل الفانكشنز صح؟
Of course.
يعني إذا
Substitution can help us solve a class of problems. This is the key difference between integration and differentiation. Differentiation, it's mechanical. You look at the function and you simply go ahead and differentiate, whatever it looks like. Okay? Product rule, quotient rule, implicit, whatever it is, you simply differentiate. Integration, you need to look at this function first. Okay? You need to look at this function first. Again, the example that we used last time is the factoring. Factoring. What do you mean by factoring? If I tell you what's 13 times 19, what's 13 times 19? Calculator? 13 times 19? Huh? 247. Okay? If you have a calculator, that becomes an extremely easy problem. It takes 1 second. 13 times 19, 200. But if I give you the opposite problem, what factors you can get from the number 247? What are the factors of the number 247? Okay? Other than 13 and 19. And 1. What factors can you get from the number 247? Other than 1, خلاص. Other than 1. Can you find any other factors for the number 247 other than 13 and 19? Yes, no? No. See, it is not an intuitive, it's not as easy as the first one. Multiplication is straightforward. Factorization is not straightforward. Simply, differentiation is straightforward. You simply differentiate. You have rules, you apply to differentiate whatever function you have. Integration is not straightforward. You need to try different things. So substitution, where was the question? So to answer the question, substitution works in a small class of problems. We're going to learn other techniques that are going to help us other classes of problems. But sometimes there are no way that we can integrate that function other than numeric. Okay, then we go to a program like Maxima or MATLAB or whatever, and then we put that function and then we evaluate the integration. Okay? Now let's look at this concept of the area between curves. Okay? And let's look at this one first, because this is a nice concept. The function to the top of your graph is an even function, and this one is an odd function. The integration of an even function from minus a to a is equal to twice the integration from 0 to a. That area is the mirror image of this area, so if I evaluate this one, then the total area is simply twice this one. The odd function, if I have this one, is symmetric around the origin with this one. So the integration from minus a to a for this one is equal to 0. Okay? Now, let's go back to a concept that we discussed last time. When we look at this graph. If I take a displacement if I'm starting here and take a displacement in this direction for 2 meters, and then go back and take another displacement in the opposite direction for 2 meters, what's the total net displacement? Zero. What's the total distance covered?
4 meters.
How do I get from that integration? How do I get 0 and how do I get 4? حد انا بس حد اتفضل. تمام. حد سمع اللي قاله زميلنا؟ طيب. What he just said is that if I wanted to get 0, this is the total area between the point of the start and the point of the finish. I simply integrate from the beginning of the interval to the end of the interval. The positive area will be counted as positive, the negative area will be counted as negative, both of them will cancel and I end up with 0. Okay? Now, the second one is not straightforward. I have to know where did I stop, and then calculate the area up to this point. And then where did I stop on the way back and calculate the area up to this point and then add the 2. Because if I go 2 meters in this direction and then back 1 meter, then the total net displacement is 1, but the total is 3. So you need to know where did that function cross the x-axis, where did that function move from negative to positive, where did that function have a root. Okay? Because the root is where it crossed the x-axis, so before that root was positive, after that root was negative. Now, I have these two curves, y is equal to f of x and y is equal to g of x. This is the red curve, this is the blue curve. And I want someone to volunteer to tell me how do I get the area between these two curves. From the information that we know so far. And it's from A to B. Somebody? Yes, sir?
We integrate f of x alone and integrate g of x alone, and then we minus the greater area minus the smaller area.
Okay. So our friend here is saying that if we integrate f of x alone and integrate g of x alone and subtract or add?
Subtract.
Subtract. Good. Any other answers?
Find the area under the first curve until the point of the section with the x-axis. And then the other one, I will calculate. And then the red curve, I calculate the whole area, and then add them with a modulus.
Okay. So basically, okay. So there are two ways that I can think about this. First, that I have the area enclosed under the curve f of x, which is going to include this part as well. Okay? I don't know what is this, and I don't know what this point is. Okay? And I want to add to it that area. Okay? That area which is enclosed between the function g of x and the x-axis. Okay? And then I want to subtract that area which is enclosed between the function g of x and the x-axis from this one. So I add 1/3 plus 1/3 minus 1/3. This is one way of looking at it. The other way is that if I calculate the total area under the red curve and the total area under the blue curve, that is automatically added as negative in that area. Okay? So if I simply include the area under the red curve and the area under the blue curve and subtract them from each other,